This is day 21 of Advent of Code 2024 Done Go. This challenge is called Keypad Conundrum. As you teleport onto Santa's Reindeer class starship, the historians begin to panic. Someone from the search party is missing. A quick lifeform scan by the ship's computer reveals that when the missing historian teleported, he arrived in another part of the ship. The door to that area is locked, but the computer can't open it. It can only be opened by physically typing the door code, the puzzle input, on the numeric keypad on the door. The numeric keypad has 4 rows of buttons, 7, 8, 9, 4, 5, 6, 1, 2, 3, and finally an empty gap followed by 0A. Visually, they are arranged like this. Like that. Unfortunately, the area outside the door is currently depressurized, and nobody can go near the door. A robot needs to be sent instead. The robot has no problem navigating the ship and finding the numeric keypad, but it's not designed for button pushing. It can't be told to push a specific button directly. Instead, it has a robotic arm that can be controlled remotely via a directional keypad. The directional keypad has 2 rows of buttons, a gap, up, a gap, then up, activate on the first row, and left, down, right on the second row. Visually, they are arranged like this. Okay. When the robot arrives at the numeric keypad, its robotic arm is pointed at the A button in the bottom right corner. After that, this directional keypad remote control must be used to maneuver the robotic arm. The up, down, left, right buttons cause it to move its arm 1 button in that direction, and the A button causes the robot to briefly move forward, pressing the button being aimed at by the robotic arm. For example, to make the robot type 029A on the numeric keypad, one sequence of inputs on the directional keypad you could use this. Left to move the arm from A its initial position to 0, A to push the button, up A to move the arm to the 2 button and push it, right up A to move the arm to the 9 button and push it, down A to move the arm to the A button and push it. In total, there are 3 shortest possible sequences of button presses on this directional keypad that would allow the robot to type 029A, and that is this. Unfortunately, the area containing this directional keypad remote control is currently experiencing high levels of radiation, and nobody can go near it. A robot needs to be sent instead. When the robot arrives at the directional keypad, its robot arm is pointed at the A button in the upper right corner. After that, a second different directional keypad remote control is used to control this robot, in the same way as the first robot, except that this one is typing on a directional keypad instead of a numeric keypad. There are multiple shortest possible sequences of directional keypad button presses that would cause this robot to tell the first robot to type 029A on the door. One such sequence is this. Unfortunately, the area containing this second directional keypad remote control is currently negative 40 degrees. Another robot will need to be sent to type on that directional keypad too. There are many shortest possible sequences of directional keypad button presses that would cause the robot to tell the second robot to tell the first robot to eventually type 029A on the door. One such sequence is this. Unfortunately, the area containing this third directional keypad remote control is currently full of historians, so no robots can find a clear path there. Instead, you will have to type the sequence yourself. Were you to trace the sequence of button presses, here are all of the buttons that would be pressed on the directional keypad. The 2 robots' directional keypads and the numeric keypad. There are the following keypads. 1 directional keypad that you are using, 2 directional keypads that robots are using, then 1 numeric keypad on a door that a robot is using. It is important to remember that these robots are not designed for button pushing. In particular, if a robot arm is ever aimed at a gap where no button is pressed on the keyboard, even for an instant, the robot will panic unrecoverably. So don't do that. All robots will initially aim at the keypad's A key, wherever it is. To unlock the first door, 5 codes will need to be typed on its numeric keypad. So for example, this. So then for each of these, here is a shortest sequence of button presses you could type to cause the desired code to be typed on the numeric keypad. The historians are getting nervous. The ship computer doesn't remember whether the missing historian is trapped in the area containing a giant electromagnet or molten lava. You'll need to make sure that for each of the 5 codes, you find the shortest sequence of button presses necessary. The complexity of a single code, like 029A, is equal to the result of multiplying these 2 values. The length of the shortest sequence of button presses you need to type on your directional keypad in order to cause the code to be typed on the numeric keypad. So for 0298, this would be 68. The numeric part of the code, ignoring leading series for that, is 29. So then you're multiplying those together and then add them. Okay, interesting. So what does our input look like? Okay, so it's just those numbers. Okay, Well, sounds like an interesting challenge, so let's get started. So I guess we can start off with, so we get the lines, we will have, let's do button groups, this will equal list of rune, then we can do for line in range lines button groups. We will actually make this, and we will give it the length of lines, then button, and we'll grab the index here. So button groups I is equal to list of rune line, and we will first double check to make sure we've got all the inputs in correctly. So we've got button groups. Okay, so we've got that. So let's go here. Let's take a look at this first, and we will just get all the keypads just so we can see what it looks like. Okay, so we have this. I think it said for both of these they start on A. Yeah, so that one goes to the left and that. So I guess we start off, should probably create these. So let's do numeric keypad, and that is equal to, what are you? You're going to be list of runes, and you will contain 7, 8, 9, and this would be a blank 0 A. 3, 2, 1, 4, 5, 6. So we've got our numeric keypad created. Now we'll get rid of this, and we will do a similar thing, but we'll call this robot keypad, and that will be caret A blank. No, I need to switch this around and do this. Oh wait, no, that was correct the first time. So do that, get rid of you, and we go left, down, right. So we have our keypads created. So we've got that done. We will do, what will we do? So we'll start off with the states for each of these, and so we could do person state is equal to point, and that would be, so x, y, we are on the numeric, we start on A. Oh, that arrangement feels wrong. Wait, did I copy it incorrectly before? Because I swear when I looked at up here when I had it. Okay, let's switch this around. I'm not sure what's going on, if I'm imagining things or not, but anyway, so we've got this. So x is 2, and we start on 0. We then, was it robot 1 state? Is that and that? Okay, how many robots are there? So we're, where does it say that? So we're controlling a robot. So we control one robot. So we have the directional pad of it. That robot's controlling another which has a directional pad. So was there 3 robots? 3 pads and this? Okay, so the outside the door, a robot needs to be sent. If that robot is controlled, goes to the A. So we have that. Sure. So that's the first robot. So we've got the numpad, we've got the control pad on that robot. So we can't get to that robot. So we have to send another robot and points to that one. We do this. Okay, there are 3 robots. So we do person state for the person. We will do robot 1 who is, let's do door state. That starts on 3, 2, 3. Okay, we'll do it like this. So person is entering the pad on the first robot. The first robot is entering the pad on the second robot. The second robot's entering the pad on a third robot, but then that one's doing the door. Okay, so I think that's what we need. So just thinking of how this works, I think we start on the door, we look at where we currently are, we look at where we need to go, and it might be, let's say, up, left. So we record that the XY coordinates we need to move, then that is passed to this robot. Okay, we're trying to get to there. We need to press up, left. So then we move to up. Was it A that submits it? Yes. So we need to go up, let's say left, up, and do that, and then so on. But then those instructions are passed to this robot. Okay, so what's the output again? The sum of the complexities of, so we will do 4 buttons in range button groups. We will do, let's see, what's this? Button presses is equal to 0. And we may as well get numeric buttons, and that would be this part of it. So we'll make you -1, and let's do num string empty string, and then we'll build upon it. So for car in range, buttons, I guess for button in range buttons, if button greater equal to 0, less than equal to 9, for to put, or button is that, num string plus equals button, don't need to do that, convert to a string first, then do that, then we do numeric buttons equals string conv dot a toy num string. So I guess with that, let's print out, see if we get what we expect. We'll say button presses, numeric buttons. Actually, we just need numeric buttons, but we'll do output plus equals button presses times numeric buttons, just so we don't get errors. And we need to make sure we handle the error with that, which gets outputted. So now let's take a look at numeric buttons. Declared not used. Okay, let's just comment this out for now. That's giving 0. Let's do print in here. We'll do button 0, this, then that should mean this, then 9, and this. Okay, so that is working. Okay, what's the output here? Num string. Get rid of that one. Okay, so A is still being added to it. Wait, how is A being added to it? I thought this condition would have handled it. Oh, the problem is I did or instead of and. Okay, there we go. We've now got that number being correctly created. So when it comes time to doing output, we have the correct numbers. Now it's a matter of actually figuring out how we even do this. So the initial idea had, we are at this location, we now need to go to the next one, I think is what would need to do. Maybe I should change this so it's a map. So map, and this would be make map of type rune return point. That's what I should do. So what, 7 times point of 0, 0. It's gonna be a lot in here. So 0, 8, 9, 4, 5, 6, 1, 2, 3, and 0, A. So this would be 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. And we go to here, which would be 1, 1, 1, 2, 2, 2, 3, 3. And let's do invalid numeric is equal to point of 0, 3. Actually, we probably don't need the make there, do we? Just this? No. Missing key in map literal. Alright, I don't need these in here. It should just be this, right? Too many points in conversion to point. It's this. There we go. Get rid of that, do this. Get rid of that, do this. Now we've got that, and we do the exact same thing for this, but it will be up, A, left, down, right. And so we need to change that to 1, 2, 0, 1, 2, and this would be like that. And we also need invalid, we'll do robot is equal to point 0, 0. So in terms of actually pressing a button, let's say you are on 3, 3 and you need to get to 0, 0, and you can't go to 0, 3. We might go, okay, it's so we're on 3, 3 and trying to get 0, 0. That is 3x and 3y away. So you might go -1 to x. Is it valid? Correct. -1 to x. Valid. Correct. -1 to x. Valid. No. Okay, we'll go -y. Correct. We still have 1x away, so we'll go -1x. That's valid. Okay. We are now on the correct x. Then we can go y, y, y. And because there's only one key that's invalid, that would make it a bit easier to do. And I guess we should also do directions. And this will be a map of point to rune. We're putting the directions that the arrows do. So if we are trying to go 0, -1 on the thing, we need to go up. So it's like, okay, we need to go up. Okay, this is the key we need to press. And then we go, this is the location of the grid that it is. And we go, okay, so that's there. Then we need to go this way to get to there. And we will do all that for left, which is... Left would be -1, 0. Up would be... Oh, wait, I need to change these. Up, down, right. Down is 1. Right is 1. And I did it again. Whoop. Forgot to do curly brace. There we go. So we've got this. We've got our button numbers made. We are now going to try get the buttons pressed. So for button in range buttons. What do we need to do? Actually, I should also check on here. What does the input look like? Is it A at the very end? Okay, A is at the very end, so I don't need to worry about... so on the number pad, I don't need to worry about pressing button, pressing A, and doing that. I just need to move it to the actual number. So for button, we've got our button. Num target is equal to numeric keypad button. And we will do, what would we do? Distance is equal to point, and that would be door state.x minus num target x, and then it would be, need to do curly brace again because I keep forgetting, and then this would be door state y minus that. So let's see how good we are with that. So let's do distance, and I keep forgetting about all of this, so let's just comment that out. No, I need u here, so I'm using u. Let's run that. Cannot use distance variable of type point. Oh, what is this? Should be print line. There we go. Okay, so 1, 1. So we start on A. 1, 1. Okay, that's working. So 1, 1. So we've got that. Now for the next one. Let's do for distance dot x does not equal 0 and distance dot y does not equal 0 if distance does not equal 0, else distance dot x. Then we can do, actually it should be other way around, because it should be a negative number that we would have to do. So switch this around. So we've got that. Now we do, what variables am I using? So we'll use, okay, we're going to switch around. We'll go from door, robot 1, robot 2, robot 3, or person. And we'll change this to door target. And we will do door distance, just so we can have absolutely everything be correct. If door distance does not equal 0, then robot 1 target is equal to robot... Right, gotta uncomment all this. Okay, we'll also include this. And what am I trying to find? And point of... Okay, I can do door x direction. This can be equal to 1, and then we do if door target dot x is greater than door. We just do if door distance dot x is less than 0. We just do door x is equal to -1. Then we do exact same thing, but now for y. So now say y and y. So we now know the direction we're going. We don't need what I was originally going to do, but if door distance does not equal to 0 and door... What am I looking for? Door state. That's what I should be using. Door state dot x minus door xdir and door state dot y. What's wrong here? Expected one expression. Okay. Does not equal door... why is this not working? Expected one expression, what does that mean? There's nothing wrong with it. Point... Do I need to just do this? Where's invalid numeric? Invalid numeric. Why isn't this... Why am I getting errors? What have I done wrong? Point. We've done door distance does not equal 0, and, which is valid code, point... Wait, is this the problem? Well, I don't know what's going on with that. Makes no sense. So let's just comment this part out, just so I can get on with some of the rest of it. So robot 1 target. This can equal right, unless if door extra is less than 0, this is equal to left. And then if this is false, if it is equal to 0, or we can't because it's invalid, we now do we can do down, or if the y is less than that, we go up. Although let's initialize this up here, and we can do if door x does not equal 0 and this, and we just do this. So is it still going to mess up if I add this back in? What does this error even mean? Expected one expression. It's a point. It has an x and a y. I have the x. I have the y. Oh, I forgot this part. No, that's in there. Invalid numeric. That is, if I just did this, would it work? Am I not allowed to create this? Let's try next x. Make that equal to this. Okay, I guess you can't just do that. I was going, why doesn't this work? Okay, well, apparently can't do that. What I was trying to do there, and okay, we've now finally got it working. So we have a way to figure out how to figure out the direction we need to go to on the keypad, the numeric keypad. We now need to essentially do this exact same thing. Let's copy all of this, and we will, for door distance, okay, let's chuck that into here now. And this should be at, what did I copy? Was it that? Okay, it's this. So we do this. We do robot 1 target. This is robot keypad, robot target key, we'll name it. Actually, what did I do for that here? Okay, we'll do robot 1 button. That's what we'll do. So we'll change that up here. Got robot 1 target and button. Robot 1 distance. That will be robot 1 state, robot 1 target. And it will be essentially the exact same thing, but kind of just replacing door with robot 1. So robot 1 wider, and changing door x with robot 1. And robot 2 button is now going to be all this. And why are you an error? Declared not used? Sure. So, I think it's then this exact again, but then it's the human. Is there anything up here where it's robot 2 state not used? Okay, there might be 2 more levels I still need to do. Yeah, that's right, there's 2 more levels of this that I still need to do. So, I'm going to grab that, and we are going to here, but we now know what robot 2 button we need to press. And we paste that in. And did I copy too much? Let's undo this. So let's grab you. I did grab too much. I should have just gone to here. And within here we do that. Okay, now we just need to replace everything in here with 2, basically. I guess one thing we should... God, this code is looking disgusting with all these loops. But I think it had to be done. Actually, so for the final one... Wait. Do I have to keep track of all of them? Okay, I don't think I've looked at this output correctly yet. So I understand this part, getting the number. Okay, I guess, how is the output created? The length of the shortest sequence of button presses you need to type on your directional keypad. So if I do left down A, so if I do left down A, that would cause this one to go here, here. So it would go down, which would cause it to press this. Wait, I'm so confused. Okay, so on the first robot, it needs to go left and then press it, which is A. So we're trying to kind of let go left A, but it starts here, so it needs to go left, down, left. So we've got that. Okay, so it needs to go left, left, A. So that is left, A. But the robot before, we need to tell it to do left and then to do A. Why are we going down first? That does make sense. It's just left A. Or maybe I scroll too far. Down, left, left, A, then right, right, up A. That makes more sense. So telling it to go to the left, and then going back here, but that's all these instructions to do that. Okay, I think that makes sense. So if I tell it to go, if I do down A, left, down, A, it's telling the first one to go, to press down, which tells the first one, okay, that's the full sequence, so multiple presses to it. Okay, so there's 64 in this. Like if I just copy this, go into a new document. Oh, it says column 69. Okay, 68. Yep. Okay, I'm understanding better. So we're still on this part. We've got robot, which we're figuring out what it needs to press, and now it's the human part, which figuring out what that presses. So let's do this. Keep getting lost with all of these. Okay, go to here. It said robot 1, which got me confused. Human. I've been using the next x variable for all of them. Next door x. Wait, is this robot 1 next x? Okay, no, that's this. So next x. This is robot 1x. Next x. Robot 2x. So this is human button. Okay, I forgot to do this. Robot 2 targets that. So human button. So we do this. Wait. Okay, back to here. I've got all of this as door. This is the current door. Now we're on to robot 1. This is all robot 1. Change this to robot 1 button. Next, robot X. This is all still robot 1, and then when we get to here, we're now figuring out robot 2. This is robot 2 button, and I need to put that back into here. And this needs to be next robot 2X, I think. Is that what that is? Robot 1X here. Robot 2X. So, door button. Figuring out the door, what we're pressing. Now, the first robot that we're controlling, the first robot that's pressing the door. We're here. We're now controlling the second robot that's to control the first robot. Okay. Now this is the human. Okay. Human button. Next, human X. Okay, so I need to include that here now. Or wait, not. Or do I? Okay, I think we've got that now. Where's the main? Okay, I haven't been doing this correctly, so where's invalid numeric? This should be invalid robot. And invalid robot. Now what else? Directions. I might have been... I think I'm handling this directions now myself. Actually, that's what I should be doing. What do I have? -1 down here. Robot extra, that should be... Actually, I'm going to just keep this commented out. That might not be needed. And then person state. I don't know if we need a person state because we can just manually press the buttons. We don't need to go in the directions, do we? So I will comment this out for now. So we have buttons pressed. We'll change this to human. So we'll change this to human buttons pressed. And this will be a string. Now where we calculated it, we'll go length of this. This will just help us see that things are working. So when we're at this point, human buttons pressed plus equals string human button. Okay, I see where I can use direction for down. Actually, direction. This should be other way around because I need to make it go in the direction I need it to. So we'll do this. We'll go to here. Human is equal to this, and then human button. We will then do robot to distance. So I also need to keep track of state. Whereabouts are we using door state? That's here. Okay, that should be... Okay, I didn't update that. Didn't update any of this. Door state. This should be robot 1 state. This should be robot 2 state. Okay, I need to change this to robot 2 state is... Well, that does not equal to robot 2 target. So we've got that. Then we do the same thing here. For this, robot 1 state, robot 1 target. And then this should be the same up here for door state. It doesn't equal door target. Do I still need distance? Well, may as well keep that. That should be fine. So human dir. Now, robot 2 state dot x plus equals human dir x. Now we do the same thing for y. And then I think this exact code is copied for the rest of them. So we do this, and it would be robot 2dir, robot 2 button, robot 1 state, 1 state, robot 2dir. Then we copy that to here, and it would be robot 1 dir. This is robot 1 button. This is door state, robot 1 dir, robot 1 dir. So let's grab this test input so we can see what it does with that. Got no idea if this will work, but may as well try. Format.print line this, and then also length of this. Let's run it. Okay, so it appears to be infinite loop, so let's try find whereabouts. So it's happening in here, and it seems to be infinitely doing that. Ah, okay, so I forgot to... What did I forget to do? What is... Okay, so we've got... Where's robot 2 state? So it's just infinitely going. Okay, so I need to restart it and go back to this condition, and it's because I used the wrong value there. Robot 2 xdir. Then robot 1 xdir, and that looks correct. So with this, we should be trying to go to the left, which is what we're trying to do. So that gets added to human pressed. Human dir, we're going to the left. Now let's look at robot state 2. That will go to the left, and that doesn't change. Doesn't equal. We will be trying to go down, so still going to the left. Okay, that's a mistake. Okay, maybe I need to add this in. Robot state 2.x does not equal robot target.x. So it should go left, which is correct. It did left, which is good. Now we'll get to here, and what exactly is the target? Robot 2 target. Something I realized I haven't handled pressing A in. Okay, so I need to include else if. So for the states don't equal. I'm not even updating robot distance anymore. I don't need this. So if they're not equal, we want this. We'll put this here as well. Oh wait, that doesn't matter. Okay, so for these buttons, okay, that's fine. And we'll add a little condition here. If they do equal this plus equals A. And I guess we could just do this and then do break. And let's do that for now. And we can do similar conditions for this. So robot 1 state does not equal robot 1 target. So let's remove that, put that here, but we'll change that to equals. We do also want this to all be updated, but we don't need to do the actual press. But what we will do after this for loop, robot 1 plus equals robot dir. Am I using this anywhere else? Okay, so I'm doing robot 2 dir. Robot 2 dir. So then we need to press A if this robot reaches it. Okay, so from when I was just recording, it's now nighttime of the next day, almost midnight, and I was pretty stuck on this. Not sure whereabouts I needed to go next. What I probably should have done, instead of doing all the nested for loops, just created a single function which looks at whereabouts we are. If we do like a depth from like 0, that could have been just the numeric number pad, and then 1, 2, 3, just the robots and stuff. That's what I should have done. But all the for loops I had just kind of made everything more complex and difficult to manage, and I kind of can't be bothered going back to it. So I just looked up some random solution, chucked it into ChatGPT to convert it to Golang, tried running it, and it works, as we can see from this input here and the number here. So what I'm going to do is I'm going to read through this code and I guess try and make sense of it along with you guys. So I guess let's get started with it. So straight away for part 1, using memoization for recording whereabouts it would be and the number of actions, I think. So it's doing string to int. So I assume it's doing like the robot, whether it's the number pad, robot, human, that start and end position, and then that outputs like the number of movements that need to be made, something like that. I guess we'll figure it out as we go through. But that's something I was thinking when I was working before, but I'd already made it too complex, and I was thinking, okay, I'll go back to this if it takes too long to run. So that's what that does. Now if we go to part 1, just doing normal stuff, grabbing the string input and turning it to the code. Total complexity, that is the output. So let's see, code, that's the input. length, that's the amount of commands needed to be ran by the human. Then complexity is the length times the code number. So the main bulk of the code is in this min length, and something I noticed is this limit and limit of 2. So I assume I saw on part 2 one, it's got 25 for that. So I think it's the amount of robots that are being used. I mean, I'm getting confused by just the amount of all this. It was door, robot, human. So 2 robots, I think it was. No, I can't remember. It was like 1.5 days ago I was working on this. But let's go to min length and see how it works. Okay, so as you can see here, do it using the memo. Actually, it's printing it out, although I don't see it being printed out. Well, no, that's not printing out, it's formatting it. So sequence depth limit. So sequence, I assume is, what would sequence be? I assume that's just the key presses. The different key presses, and the depth is, okay, so depth is if it's the keypad robot human. That's how that works. Oh yeah, as you can see from here, I copied some Python code for it, and ChatGPT has added comments based on that. So, got the memo key, that's created. Val okay, it's checking to see if this value has already been cached, then just return the value. Otherwise, we do the actual bulk of the code. So we've got the avoid positions based on where the blanks are in the keypad. That's all good. So current rune equals capital A or lowercase a. So if we go to the top here, in positions, they've got everything grouped together. So capital A is for the numeric pad, and small a is for the robot pad. So go back to here, it's doing this, and it's grabbing the position of A. So initializing for total length, and for character in range sequence. So it's grabbing the next position of the sequence, or the number in the the number in the sequence. So now it's doing all possible ways to get from current position to next position. So it is building that up. So you've got start, end, and the avoid points. Got a list of moves. It's doing similar thing to what I did, where delta x less than 0, then it's up, otherwise it's down. But it's adding all the moves to it based on the direction that it's going. And then it's same thing here, but for left and right. Although something I noticed, it's using left and right for y, and up and down for x. So that was a mistake on their part, but that's fine. Generate all possible permutations. So it's using, using moves? Okay, so we've got this function, permutation of runes. So it takes AR, not sure what that is, but it's got start. If start is equal to the length of AR minus 1, it's cloning it. Okay, so let's look at this comment. So permutations of rune returns all permutations of the given slice of runes. We'll do it in place with a standard backtracking approach. Okay. I'm not exactly sure what this is doing. So it's iterating over the length of the array. Start 1. So it's switching. But why is it switching? I'm not exactly sure. Is it just creating every possible way that you do, like up, down, left, right and stuff? I think that's what it's doing. Okay, so whereabouts was it used again? Here. And we're passing, so that does appear to be what it's doing, but we've got all perms going over the all permutations. We've got the permutation string. If does not equal perm set perm string, then we're setting that to true. What is okay, that's this perm set valid sequences. So now we're going over all the permutations. So for each permutation of moves, we verify we never land on a void. Okay, so we're removing all possible permutations where it does land on a void. Sure, that makes sense. We're adding that to the valid sequences. So if valid sequences equals 0, if no valid sequence is found, return A as a fallback. Okay, so that's a somewhat large function. So back to here. So we've got all the move sets. If depth greater than limit, so we're at the last one. So shortest is equal to the length of move sets is 0. Then for move in move sets, if length of move is less than shortest. Okay, that's like partially makes sense. Something I wasn't properly looking at was handling the smallest amount of movements, I think. Actually, no, I think I was fine because you'd have the robots like move, and then it would kind of always reset back to A as it presses it in. Actually, no, I wasn't. So with the number pad, I wasn't reset. That wasn't meant to be reset. So it's like the first robot's always on a kind of a certain position, and then it moves up. Yeah, I don't think I was handling the state of that correctly. Oh, I can't remember though. But anyway, if you're at the very end, then you're doing total length plus equals shortest, which is fine. Otherwise, okay, we've got the minimum. Going over the resets, finding the minimum length. Wait, this is a function. Okay, that's okay. Min length. So that's going through the whole thing again, but we're going next depth. So we're starting on human. We then... Okay, so that's the move sets. Wait, 4 move in move sets. So this is ran multiple times. So there will be multiple moves in the move set, and we're running it multiple times over each robot and person. And then based on the length of that, we are putting it in. Okay. Not entirely following, but sure. So with this one, if none found, fall back to direct path. Shortest that, and then return total length. We've got the calculate complexity, where it's basically just doing what we did, where if the character in the code is greater or equal to the rune value is greater or equal to that, we add it. Otherwise, do nothing. So, not entirely following part 1, or I guess just how it was done in general, but it is code which works. So let me retrieve my part 1 input again, or I should say my own input, and let's put that back into here. Let's run that. So for part 1, we got 217662, which is correct. So let's go on to part 2. Let's read this. So just as the missing historian is released, the historians realize that a second member of their search party has also been missing the entire time. A quick lifeform scan reveals the historian is also trapped in a locked area of the ship. Due to a variety of hazards, robots are once again dispatched, forming another chain of remote control keypads managing robotic arm wielding robots. This time, many more robots are involved. In summary, there are the following keypads: 1 directional, 25 directional keypads that the robots are using, and then one directional which you're using, 25 directional robots are using, and then 1 that a robot is using. The keypads form a chain, just like before. Your directional keypad controls a robot which is typing on a directional keypad, which controls a robot which is typing on a directional keypad, and so on, ending with a robot which is typing on the numeric keypad. The door codes are the same this time around, only the number of robots and directional keypads has changed. Find the fewest number of button presses you will need to perform in order to cause the robot in the front of the door to type each of the code. Okay, so it's basically like the same thing, except instead of 2 robots, it's 25. So with the solution I was originally doing, that would have been impossible to manage, and I would have had to have turned it into a function, and yeah, I'm glad I just looked up a solution and ChatGPT'd it into Golang, was I don't want to be managing that at midnight while I'm trying to do this, and then I've also got other stuff I need to record, so yeah. On to part 2, down here, it's essentially the same from what I can see, just instead a 25 in here instead of a 2. So, I can't remember where I got this code from because I'd looked at it a bit ago, chucked in ChatGPT, then I had to go off do more things again, so whoever you are, thank you. But, so, we already ran it. 43822 is the solution for this one. It's not right, the answer is too low. Interesting. That can't be right, can it? Because part 1 was far higher. Let's copy all this, chuck it into here. Let's rerun that, just see what it gives. 217662. Okay, so it's giving the right number. Now 25. That should be way more than just 200,000. But it's giving 43822. That is weird. Okay, so I grabbed the code again, chucked it into ChatGPT, told it that it didn't work, and that looks more like the number that we should be getting. So I copy that, chuck it into there, and the number is still too low. Interesting. So, actually, what was part 1 output for it? That looks correct. Let's switch to this. Switch to the test input. Actually, switch back. Let's take a look at the solve 2. What are the chances that Mickey 26 works? Actually, I should have stuck on this for a little bit, just so we can see what the part 1 is, because we know what part 1 is meant to be. Okay, so it's too high now. And then based on that, 243... Yeah, it's going too high. Okay, hopefully second time lucky with ChatGPT. Oh yeah, I need to remove this point at the top here. Now run it, hopefully works. Okay, not sure what that number is. 227928. Nope, that is wrong. Gotta try some more. Okay, so I've been ChatGPTing it a bunch more and finally got the correct output for part 1, and part 2 looks to be correct. So let's go here, submit it, and that is part 1 complete. I wish I could have solved this myself, but kind of messed myself up by how I was approaching it originally with all the nested for loops. So messed myself up that way, and there was too much work I needed to do to get it fixed, and I already got like an hour or so I need to edit and all that sort of stuff, and kind of couldn't be bothered. So I guess I had to cheat to get this answer, but anyway, if you like this video at all, make sure to like and subscribe.